In this example, we're asked to match each line with its slope. And here is the graph, and every different color represents a different line, and they're also labeled. So this is line A, line H, line G, etc. And each of them were given specific values, and we have to find the slope that corresponds to the given line. So I put the drop-down menu for line A here. So the possibilities are undefined, 2, 1 and 1/2, 0, negative 1/2, negative 1 and 2. So let's start. So we know how to find slope by finding 2 points on the line and using the slope formula. And we probably could do this here. They all pass through the origin, and we could make some estimates for some of these, what the points may be. This looks like the point 10, 5, so we could use that to help determine the slope. But instead, let's think about the properties of slope and the categories that we've learned thus far. So we know that vertical lines look like this. They go straight up and down, and their slope is undefined. Okay? And the reason for that is if you think of a vertical line, nothing could be steeper than a vertical line. So someone could say, this has a slope of 10 million, okay? And you would say this is even steeper than 10 million because you never move to the right and go up for the slope. You are just going perfectly straight up. If you looked at this algebraically, we'd see that the denominator is 0 and dividing by 0 is undefined. So that's one type that we're going to consider. Then we have horizontal lines. And horizontal lines look like this. And their slope is 0. And remember, the reason being is that the slope measures, again, the rise over the run. So you move over some amount and up some amount, and it's the change in the y over the change in the x. Well, if you're on a horizontal line, notice your x keeps changing, but your y is always 0. So it'll be 0 divided by any non-zero number, which gives you a slope of 0. You can also think of it as just being flat. So if you're walking along this would be flat. You're not walking up or an incline. You're not going down a decline. It's just flat. Just like the vertical line is straight up, it couldn't be any more straight up. Now, let's think about lines with positive slopes. So positive slopes go up from left to right. So this has a positive slope, this has a positive slope. So these are positive. You could think of if you hopped on the line, if you were walking on this, maybe on a treadmill, this would be an incline. You would be going upwards. And here you would be going upwards. So positive slopes have lines that go up from left to right. And similarly, negative slopes go down if you look at them from left to right. So I'm going to make the axes, and this line has a negative slope. I don't know exactly what this slope is, but I see as I go from left to right, it would be like I was walking downhill. So now looking at our lines that we have here, I'm going to focus on these two quadrants. A is our vertical line. So we said vertical lines have slopes that are undefined. So for A, we would have undefined. slope. Next, let's find a horizontal line, and that would be line F. So F would have a slope of 0 because it's a horizontal line. Now let's look at the remaining ones. These three, H, G, and D, notice they're all going up from left to right, so these are all positive slopes. And we can attempt to compute, based on the values that are given, what exactly their slope value is, but we know that they have to be 2, 1, and 1/2. So the steeper the line, the larger the slope. So take a look at these and think about which one you think is the least steep and which you think is the most steep. And again, I like to think of walking up it. It would be easier to walk up this incline than it would this because this is steeper. So that means D is the smallest positive slope given, which is 1/2. Line G is the second smallest, or in between H and D, of the positive slopes, so it has a slope of 1. And line H is the steepest positive slope, so it is a slope of 2. Now we're going to use a similar idea for these three lines. So all three of these lines have a negative slope. So just like when we thought about which one is easiest to walk up or most difficult to walk up, you could think here about walking down. So this is the least steep line, but it does have a negative slope. This one has a little bit larger decline, and this one has the steepest decline. So looking at these values, this one would match with the smallest negative value, which is -1/2. So it's the smallest negative slope. Then we have C would match up with a slope of -1, and finally B would be a slope of -2.